Hey everyone, welcome to our video lesson on regression models. You are definitely going to need your calculator today, so make sure you have that handy. Grab your notebook and something to write with, and let's get started. Okay, regression models are just a fancy way of naming equations that are going to help us do two things. Remember that we're in the statistics unit, so the goal of our statistics now that we're in high school is to take a big data set and look at the data that we've collected and then maybe make some predictions either about what we can expect to happen in the future or what's most commonly happening or how we can describe that data. So regression models are going to help us do two things. They're either going to help us interpolate, which means to make predictions within the data range, or they're going to help us extrapolate, which means to make predictions outside of the data range. So if I took a big data set of all of the region scores for students in ninth grade last year, I might want to predict what's going to happen if I compare it to how long that they studied. I might want to predict what the score was for someone that studied a certain amount of hours that I did collect. Or I might want to find out something obnoxious, like what happens if someone studies for 10,000 hours? What's the kind of score that they're going to get? Not that they can get anything over 100 on a Regents exam. All right, but in order for us to make really mathematical predictions about either what's happening within the data or what we can expect outside the data, we're going to use regression models. Now, the most common regression model is linear regression, and you guys have already had experience with this. Okay, linear regression is just finding the line of best fit. All right, now as far as I know, when you were in middle school and you did statistics and you did scatter plots, you created the line of best fit by hand by finding 2 points within your data set, trying to adjust your ruler to make sure that it was right down the center of all of those different points that you plotted, and then you found the slope and the y-intercept, and that became your equation. Luckily now in high school, we have our trusty calculator to assist us, and it is going to help us create that equation that actually is the line of best fit with no guessing. And then once we have that equation, then we can use it, like I said, to make predictions. So I have an example here. And this example has collected data about people and their average target heart rate. And this is heart rate for like when you're exercising. What's your target heart rate going to be to really get your cardiovascular system running, if you will. Now, I just covered up a couple of questions because I want to focus on this data here right now. As you'll notice, we only have specific ages that have been measured, 20-year-old, 30-year-old, 40-year-old, and so on, and nothing in between. So the only thing I know is that at 20 years old, your average target heart rate should be about 138, and at 30, it should be about 129. And as you get older, your average target heart rate goes down because your body is not as capable as it was when it was younger to handle the things that it could. So the first thing that I'm going to do is I'm going to input the data into our calculator, which we have done before. So if you go into Stat and you click the first option, Edit, we're going to use age as our list 1 and target heart rate as our list 2. In these two sets, age would be our X value or independent variable, so that's going to go into list 1. So go ahead and grab your calculator and enter in the ages into list 1. Okay, and then the target heart rates, remember they should match up. I want 138 to go with 20 and nothing else, so I'm going to make sure I plug them in order. 118, 112, and 107. Okay, and now my calculator has that information to be able to handle. Now we're going to do a couple of things here. The first thing I want to do more as a review is to create a scatter plot. This is what we did in the last lesson, but I want you guys to see what this data set looks like visually so that you can get a sense of why we're doing what we do in the future. So again, we're going to go to y equals. I'm going to make sure that my plot 1 is turned on. It should be highlighted or bolded, however you want to see that. If it's not, use your arrow to go up, hit enter so that it is turned on. Make sure nothing else is in your y equals columns so that your calculator isn't getting confused. And then we're going to go to zoom and then we're going to choose option 9, and that is going to give me my scatter plot. Okay, now you guys can see that this has a negative correlation because as my x increases, my y values decrease. It also has a pretty strong correlation. I would expect this correlation coefficient to be pretty close to -1 because all of those dots almost directly line up in a straight line. Now, what we're going to do in step number 2 is we're going to find the linear regression model, aka the line of best fit. And I'm going to let my calculator do it because it can get really, really exact and it can find the specific values that would give us a line that fits this data best. So it does tell me to round to the nearest hundredth, which gives me a heads up, expect some decimals. And what we're going to do is we're going to go back into our stat menu and I'm going to go over to calculate. Now we used option choice 4 in the last lesson when we were looking up the correlation coefficient, and what we're going to do is we're going to go back into that option and we're going to use the other variables that were listed there as well. So linreg stands for linear regression. You want to make sure you're choosing the option that says ax plus b, very similar to mx plus b, because there is another option for linreg, but that's not the one we're looking for. So I'm going to hit enter here. Okay, we did put our x values into list 1, our y values into list 2. I don't have any frequencies, so I'm leaving that blank. And then this is to store the equation. We don't have to do that. So I'm going to scroll down to calculate, hit enter. And what your calculator has done is in the format y equals ax plus b, they just replaced the m with an a. They've found the specific a value, the specific slope, and the specific b value, which still is the y-intercept, that is going to represent the line of best fit for this data. So if I take our numbers here, and it does say round to the nearest hundredth, I'm going to take the a value, which would become -0.59, and the b value, which would be 147.41 when I round it correctly. Those are going to go in the spots of a and b on my equation at the top. So this is going to say y equals -0.59x plus 147.41. So my calculator has found the slope and the y-intercept necessary for the line of best fit. And now I have this equation for the line to represent predictions, if you will, to represent the overall data as best as we can. So now if I have what's called a regression model, this is the regression model, now I can make those predictions. I can either interpolate or extrapolate. And I have 2 examples here to show you guys exactly what that looks like. For example, if I asked you, what is my target heart rate? Okay, I'm 28 years old, and 28 is not listed in our data set. You can kind of guesstimate where 28 might be, somewhere in between 138 and 129. But instead of guessing, instead of giving your best estimate, we're going to use the linear regression model, and my age is going to go in the x value. So I'm going to plug in y equals -0.59 times 28, because that's how old I am, plus 147.41, and I'm going to go ahead and put that into my calculator. -0.59 times 28 plus 147.41. Okay, and it thinks that my target heart rate should be about 130.89. I'm going to round like these are rounded to the nearest whole beat per minute, and I'm going to say 131. Okay, so what I want you guys to do, the next question is, what is your target heart rate? And we've got some people that are different ages, so I want you to take a second, pause the video, plug your age into your regression model, plug that expression into your calculator, and figure out what your target heart rate would be. All right, so hopefully you got something that's higher than 138, because as our trend would suggest, someone younger than 20 would have a target heart rate higher than 138. But your target heart rate is obviously contingent on a bunch of other different factors. So please don't take this and think that that is your specific target heart rate. That is just according to this collection of data and this regression model, that's what your target heart rate should be. Okay. The last thing that I want to cover here is what if our data set doesn't exactly fit a line? We were lucky when we pulled up our scatter plot when we hit zoom 9, it almost exactly fell into a line. But what if I have a scatter plot that looks like one of these two? Okay, I am obviously not going to be able to put a line of best fit through this scatter plot. And the line that would best fit this would probably not fit well for the majority of the data. If my line went up like this, or if it went down here, it's not going to be able to really truly predict where that data is going. So we do have other regression models. We don't have to use linear regression. If you're given a table of values or a scatter plot and it seems to not have that positive or negative linear correlation, then when you go into stat, after you've put in all your values, we do have other options in the calculate menu. Okay, if something looks like this, that's when it looks like a quadratic. Obviously, it can be this upside down or a U shape, a quadratic regression. So I would choose option choice 4 and I would hit enter until I get down to calculate. And now my calculator is still reading the heart rate data that we plugged into it. So this wouldn't really make sense for my scatter plot, but it'll still do its best to give you the A, B, and C values that would go into the standard format AX squared plus BX plus C. We'd round, plug in, and then we'd have a quadratic equation to represent our data. Okay, and then if it looks like this, you might have been able to guess, that's our exponential regression. So I would go into stat, calc, and this option is all the way down at the 0 mark, EXP, REG. Same thing, make sure it's L1, L2, get down to calculate, and your calculator will do the best to find an A value and a B value that fits into our standard exponential equation. So like I said, linear regression is the most common that you guys will see, but we do have other options down here. I'll be putting together some practice for you guys to help you not only find the linear regression models, but also use them to interpolate and extrapolate. And then in the future, we'll talk about how to compare the 3 different models and decide which equation is going to fit your data best. If you have any questions or if I can clarify anything within this video, please feel free to reach out. Otherwise, have a great day, everyone.